All right, today we're going to study section 1-3, fractions and mixed numbers. So what we're going to learn is how to write fractions in their simplest form, and then how to multiply and divide fractions, and then how to add and subtract fractions. And surprisingly, adding and subtracting is a more difficult operation than multiplying and dividing. And then we'll talk about how to perform addition and subtraction on mixed numbers. All right, so in order to write a fraction in reduced form, we have to understand the concept of product, which means multiplication, of prime numbers. A prime number is a number whose only two factors are 1 and itself. So if we want to write the prime factors of 54, pick any two numbers multiplied together that would give you 54. So we could say 2 times 27. We could have picked 3 times something, but we're going to pick 2 times 27. Now, since 2, the only way you can get a 2 is 2 times 1, itself times 1. We're going to circle the 2. 2 is prime. We're at the end of the factorization tree on that branch. But 27 can be 3 times 9. And this 1-3 is a prime. But then this 9 would be written as 3 times 3. And once you go through all of the branches, you'll come down with some ending nodes that are prime numbers. So if we were going to write 54 as the product of primes, we would say 54 would be 3 times 3 times 3 times 2. And some people would write it as 3 to the third times 2. Those are equivalent. But you need to be able to find the prime factors of any number, because what you're going to wind up doing is canceling or reducing if you have the same factors in the numerator and denominator of a fraction. So this is an important topic. So why don't you go ahead and do practice 1 in your book. It's actually on page 16. Here's practice 1. I don't really want you to see the answers too much, but you can tell it's a practice problem because of the little green box. So turn the video off and do practice 1. All right, so let's continue with example 2. So if I have the fraction 20 over 35, 20 is in the numerator and 35 is in the denominator, and I want to write that in lowest terms, what I'm going to do is rewrite the numerator as the product of two numbers. I'm going to say that's 20 is 5 times 4. And you know what 35 is? 5 times 7. Now this is something that we're actually doing very explicitly at this step, but this is something that you might actually wind up performing this operation mentally. We can cancel out or reduce, since we have a 5 in the numerator and the 5 in the denominator. We can factor out the 5 and reduce. Remember, any number over itself is equivalent to 1. So this 5 over 5, that's like 1. Any number over itself is like 1. So that's like 1 times 4 over 7. So what's left? All I've got left in my numerator is 4, and all I've got left in my denominator is 7. So 20 over 35 is equivalent, has the same value as 4 over 7. It's just that 4 over 7 is in its simplest form. So why don't you go ahead right now and try practice 2. Okay. Class, from example 3, we're going to multiply fractions. So when you multiply or divide fractions, they do not have to have a common denominator. When you multiply fractions, you just multiply the numerators across and you multiply the denominators across. So I'm going to show you two ways to do this. The first is to multiply first and then reduce your answer. That's the first way we'll show it. The second way is to reduce first. And that's really the way I prefer, but reduce first and then multiply. So if I have 2 over 7 times 3 over 10, when you multiply fractions, you just multiply your numerators. 2 times 3 is 6. And 7 times 10 is 70. So I have 6 over 70. However, now I have to reduce. And since one of the hints is if both numbers are even, they end in a 0, 2, 4, 6, or 8, they can be rewritten as a 2 times 3 and a 2 times 35. And why would I want to do that? Because then I can reduce numerator and denominator by 2. So your final answer for this problem is 3 over 35. 2/7 times 3/10 is going to equal 3 over 35. So you always want to write your answer in reduced form when you're talking about fractions. Now I find it easier to reduce the fractions first and then multiply. All right, so if we look at 2 over 7 times 3 over 10, I'm going to rewrite this 10, replace it with 2 times 5, right? Because that's what 10 is equal to, 2 times 5. And now I have the same number in the numerator and in the denominator. I have a 2 in this numerator, and since you're multiplying, you're going to multiply across, so it's okay that this is the numerator of the first fraction. And I'm going to factor out or reduce by that 2 in the second fraction. 3 is a prime, cannot be rewritten. The only way you can get a 3 is 3 times 1. 7 is a prime. The only way you can get a 7 is 7 times 1, and so is 5. So that's actually become a 1. 2 divided by 2 is 1. So now you're going to multiply across. 1 times 3 is 3 in your numerator, and in the denominator, 7 times 5 is 35. So you can see you get the same answer regardless if you reduce first or if you multiply first. All right, so why don't you go ahead and try practice 3.